Hello, students. I had a couple questions come up out of the Chapter 6 review. And so I'm going to hit those. It was question 32 and 48. I know, separated by 16, so must be something about the number 16 that worked really well. Let's take a look. So this one right here, 32. In water, the weight of oxygen to the weight of hydrogen. So oxygen to hydrogen is 8 to 1, roughly. It says approximately. So again, there's no units on this. It's an 8 to 1 ratio. So it could be 8 ounces to 1 ounce. It could be 8 pounds to 1 pound, right? 8 grams to 1 gram. So we got this weight idea. I guess I'm equating weight with mass, but outside of the gravitational constant, I think we're okay. So how many ounces of, now, oh, careful, ounces of hydrogen are in 1 pound of water? So I do need to come back to the good old American system here and know that 1 pound is equal to 16 ounces in terms of weight. Okay, in terms of weight, just so we're on the same page, not in terms of fluid ounces, which measures something different. I know. Go us. We're doing great with that. Okay, but now notice this ratio here. This ratio is part to part, oxygen to hydrogen, not part to total. So if I came over here and I said, well, then oxygen to total would be 8 parts oxygen to the 8 and 1, 9 parts total, which means hydrogen would be 1 part hydrogen to 9 parts total. And this is the ratio that we need to use because it says how many ounces of hydrogen are in 1 pound of water, and water is the combined piece. So what you can do is just set it up 1 hydrogen to every 9 total. And how many ounces are there in 16? Again, because it's 1 pound of water. 1 pound is 16 ounces, and that's the ratio I have. So again, for me, if there was a, you can choose many different ways to do this problem. One of them is using the properties that we've talked about in this section. One of them is you just switch these two and you get it. So that leaves me x over 1 is the same as 16 over 9. And you're done because x divided by 1 is just x. So that means x would be 16 ninths ounces or 1 and 7 ninths ounces. That's that way. If you want to go the other direction, you could certainly take one of the other approaches, call this x over 16, multiply both sides by 16 using the property of equality. These cancel, leaving you x over 1, and you get 16 over 9, and you get x equals 16 over 9, which is exactly the same thing. Okay. Could you cross multiply? Well, of course you could if you really chose to. I'm not advocating that. I think it's usually extra steps. But if I cross multiplied, I would end up with 16 is equal to 9x. And then I would divide by 9 on both sides. And guess what? I end up with x is equal to 16 ninths. So again, 16 ninths, 16 ninths, 16 ninths. You're going to get the same result no matter which way you do it. I just showed a few different ways. Hopefully that helps if you were kind of thinking about it. Think about solving it in a different way. So I think this is when people say in class, is there a particular way you want me to solve this? The answer is no, there isn't a particular way. I tend to try to find ways that are efficient. And that's why this last technique that was used over here, this cross multiply, is not my favorite. Notice I had to multiply, then divide. So that's 3 steps I have to take, each one of them with a chance to make a mistake. Over here, the first one that I showed you, all I had to do is switch the 16 and the 9 and I'm done. So again, extremely efficient. If I wanted to multiply by a single number on both sides, that again is a very efficient approach because there's only one operation that I'm doing, not 3 operations. So the traditional approach is typically, and you might remember in class, Jenna did mention it. She's like, you cross multiply. That is a very traditional approach. And I'm not saying that it doesn't work, but it's also long. And additionally, it gives people the wrong idea of what to do with fractions. They will cross multiply everything. But instead of realizing you can only cross multiply when you have a proportion. it has to be a proportion. It has to look exactly like this, and it can only look like this. That's when you can cross multiply. Okay. So if you really want to say, well, wait a minute, why is it that I can only cross multiply during that situation? The reason is if you look at what you are actually doing, you are actually floffing these two. Okay. You are creating a times 16 and a times 16. You're doing a times 9 and a times 9 to create a common denominator. And then because the denominators are the same, the only thing that could be different is the numerators. So you basically are recreating the numerators here without the denominators at all. And that's kind of a quaint way of saying what you're doing. That's why this type of problem is 3 steps instead of 1 step. Not that it's wrong, it's just long. So going back to Dr. Phil. All right, let's see here. Yeah, this is the woman's will. She decreed that her cats be shared among her 3 daughters as follows: half of the cats to the eldest daughter, a third of the cats to the middle daughter, and a ninth of the cats to the youngest daughter. Since the woman had 17 cats, they decided they could not carry out their mother's wishes. The judge, who was kind of overseeing this, agreed to give them a cat so that they could do this. And then half of that cat, half of the total now, half of 18 is 9, a third of 18 is 6, and 1/9 of 18 is 2. 6 plus 9 plus 2 gave them 17. The daughters were able to divide the cats up, and they actually returned the borrowed cat to the judge because they didn't need the extra one. Has the woman's will really been followed? So the question is more about, has it actually been followed? And so if you're going through this problem, hopefully you looked at it before you jumped to any conclusions and kind of said, well, wait a minute. I want to give half of the cats to one person, a third of the cats to another, and a ninth of the cats to somebody else. Maybe we should kind of be working through this, right? So if you take a look here, if you just added these two fractions together, those are thirds and halves. So I will fluff. And now I have 3 over 6 plus 2 over 6 plus the 1 over 9. And that leaves me 5 over 6 plus 1 over 9. Now just pause for a minute. If you're trying to get to all of the cats, that would be one whole group of cats. I have 5/6 of all the cats. I would need to add 1/6 to get to 1. But this woman's will said, no, do 1/9. So at the end of the day, if you did create 18ths out of this, because that's the LCM, you'd have 18 here, and this would be 15 out of 18 plus 2 out of 18. And so as it turns out, the idea was here, half, a third, and a ninth, they add up to 17/18. Now, proportionally, each daughter seems to have gotten that piece. So again, has the woman's will really been followed? I'm going to leave that up to you to answer. If you think her will has really been followed, if this is what she wanted. But if you had a collection of money and you said, here's how I want 17/18 of this money to go, people might be wondering, so what do you want us to do with the other 18th? Especially when you didn't have that many to begin with anyway. So in any case, there you go. Could you say, well, wait a minute, couldn't I scale this back to the number of cats that she had? And the answer is, well, I'll leave that part up to you because maybe that's part of the question. So if this is what she had, but this is supposed to be equivalent to one group of cats, right? 17/18 is equivalent to one group of cats. Yeah, then perhaps you could say, well, wait a minute, maybe what I need to do is scale this by multiplying so that I can get to 1, which again is this is like the multiplicative inverse. So we can say, okay, we're going to take your wishes, and because we would have to scale this will by 18/17 to get to 1, we could scale each of the individual pieces by 18/17. And if you take a look, if you divide that, that is what? 9/17, right? And the next one, a third, 1/3 of 18/17 is 6/17, and 1/9 of 18/17 is 2/17. So there kind of helps you represent how would it link back to the 17 cats. So you could use scaling. You might even think, hey, that you can't do that. That's fine. But what do you think? Has the will been followed? All right. So there's the two questions there. Hope that gets you on the right track. Off you go.